There we go. We're on. Okay, so your task today is to actually do the graphical vector addition problems. So what I'm going to do is I'm going to sketch what I'm expecting for you to show me on each of these problems, because there's really no math to be done. This is, can you draw stuff the right length, point it in the right direction, and connect them the right way? And that's pretty much the heart of what you're doing. So as a reminder, you have 3 problems, and as far as basically where you lay them out on the graph paper, if you kind of imagine your paper like this, you should have plenty of room in each of these 3 places to do the 2 vector, the 3 vector, and the 5 vector problem. Now, what I'm going to do is quickly kind of sketch the first one. The first one was D plus G. So you have a master list, so you have an idea of already where D and G go, so that you're going to be able to adjust kind of the starting spot in here so that things will fit. But the idea is, once you decide where to start the problem, you are going to make a nice, neat set of coordinate axes at that beginning spot. They do not have to be huge, okay? And so you don't have to really extend your axes very far. I am going to ask that you add these together in the order that I put them in the problem, okay? Literally, you could add them in whatever order you want, but in order to make them fit kind of in here, that's why I put them in a particular order. So your first task would be, once you establish your coordinate axes, to meticulously draw D, which would take you over in that direction, okay? So you measure the angle right, you draw it the right length, and once you have it drawn, I want it labeled, okay? Now, at the end of D, you need to pretend to orient your protractor the right way. You need to establish a new set of coordinate axes. Now, what I'm going to do right now is theoretical, but I want you to do this just as a reminder. All I want you to do at the end is dot in, very lightly, another kind of coordinate axes. And this one should be relatively parallel to this, because the reminder is you need to draw G so that it is on the end of D, so it points in the right direction. But you need to orient your protractor, and I'll hurry and grab one here. When you would have drawn D, essentially you would have been looking at your protractor like this. You'd be using it upside down. But on the end of D, you need to put your protractor in exactly the same way that you need it, that you would have put it here. On your protractor, you have a horizontal line that connects 0 and 180. You have the center of your protractor. Your center of your protractor needs to go on the end of D. But you need to kind of play with it until that 0 to 180 line is parallel to the blue grid, the horizontal lines in your blue grid. And the center to 90-degree vertical line is parallel to all the other vertical lines. Once you feel you've done that correctly, then you can measure your angle to G, which where G looks like it'll kind of go over in this direction. You label G, and then if you had a third vector, you'd do exactly the same thing on the end of this vector and draw the next one until you're done with all the vectors for your problem. Now, once you finish your chain, what you're going to have to do is take your ruler and you are going to have to draw the connecting line between the tail of the very first vector and the tip of the last vector. Now this should take you back to your original set of coordinate axes. This one is your R. So it's going to be easy enough to label properly, but you're going to have to put an arrow indicator on it, and it has to point the right way. And it is the only vector that is not connected tip to tail in your whole picture. So however you make sense of which way does R point, I'm going to leave that up to you. So you're going to measure how long R is, and somewhere near your picture, you are going to have this exact thing. You're going to have R equals, and you'll have these parentheses. And once you measure how long R is, that value goes in here. And then the second thing is you need to give it an angle. And that angle, I want you to label in this picture. You don't have to label the angles for the individual vectors that you're drawing, but for R, I want you to label it. And in this picture, R comes all the way around to there. And this is your theta. And you're going to put that angle here with how many degrees it is, and you're done with this problem. And then you can go on to the next one. So if you are missing any of this formatting stuff, you'll get dinged on that. Yes?
Also write the original vector with G, or no? Like the one that was originally connected to the origin?
No.
Oh, we don't write that one?
No. I do not want you to clutter up this picture. I only want you to draw the vectors in the place in your vector chain. So the idea of drawing them all first and then moving them around, I do not want you doing that. Yeah, Maddie.
So what if you put like G there and you don't make a new axis, you just use the original axes to find R?
Like if you put G starting from here, you won't get the right answer. So that's why what I am asking you to do is to not clutter up this thing by like drawing them all where they originally exist and then having to move them around. I want you to draw the first one, and at the end of that one, you draw the next one. And then at the end of that one, you draw the next one, and you just keep doing that until you have connected all of the vectors, and essentially you are drawing them in the place where they should be to begin with. And then when you get to the end of it, you connect the tail of the first one, the tip of the last one, measure how long it is and what direction it points, and you're done. Okay?
Do we need to include like the little theta and the circle angle?
Yes, everything in here. You do not need to give me thetas and lengths for the constituent vectors that you're putting together, but I just want to see this.
Oh, okay.
Because I will tell you, this is what I get most that's wrong. Then I know you're not going to have the right answer because you're not seeing the right angle that you're supposed to measure in the first place. Okay? And that's the whole point of having you do this, so that when we talk about vectors without, having to draw a super accurate picture in your head, I'm hoping you're going, I can visualize what I'm actually doing with the math on my paper. Okay? Yes, Arthur?
What do we do if we have a half degrees?
If you are right in the middle, feel free to do a half degree. Don't go any, I do not want to see like 0.3 or call it a full degree, a half a degree, and that's it. And then when it comes to the length, if you feel like you want to, if you're in between millimeters, you can go to half a millimeter. So when you're doing centimeters, you definitely should be able to get to the nearest tenth of a centimeter. If you're right in the middle, you can go to a 0.05, but that's the most, okay? And as you're doing the problems, two things, just like when you drew when you drew your little star-shaped pattern. And this is why I'm super controlling about this. You all should have exactly the same picture when you're done. So when you're finished and your friend is finished, you should be able to say, what did you get? And when they tell you this many centimeters and this many degrees, if you differ significantly, somebody did it wrong. Or they might have measured it wrong. But this is why I like to make you guys physically deal with this stuff, because down the road, we'll just play with it mathematically. But people who only learn that when you like start drawing pictures are like, what the hell is that? It's like, that's what you're doing with your math. I want you to have kind of a graphical understanding of what we're going to be doing starting tomorrow when we treat vectors mathematically. Okay, I think that's it. So you got 3 problems to do.